Hi everybody. So now we're back and we have a slideshow here that has four different body systems. And so you are going to be able to access obviously all of this on one slide deck. It's going to be linked in your unit work. But what I'm going to do is I'm going to do separate screencastifys just because I think it might be easier if we keep less content on each one. And then if you're good with the bones and the muscles, but the circulatory system is a little wonky for you, you can go right to the circulatory system. So the first one we're going to do is we're going to do the skeletal system. And the skeletal system, I think everybody sort of kind of has a handle on it, right? Most people know what a skeleton is. And so what I want you to get out of this is I want you to know kind of what its job is and what its structure is a little bit, okay, and what the parts of the system are. And so when we look at the skeletal system, we look at it as is it provides form and structure for our body, form and shape. Okay, so without bones, you'd be a big pile of goo. Okay, protects our inner organs. So we have this rib cage, right, and it protects the heart, protects the lungs, which are vital organs. It allows us to move, and so it's interesting that sometimes the skeletal muscular system is actually put together as one system because the skeletal system doesn't work without the muscles, right? They're not going to move. The bones aren't going to move without muscles. And then there are other little parts of the skeletal system. So we're talking about the bones. I think that's one that everybody pretty much gets, right? Cartilage is another one. Now, cartilage is the your ears and your nose and when you eat chicken, that the gristly part in the end of a bone, that's actually also called cartilage. Part of the system is also joints, and joints are where two bones meet. There's different types of joints. There's ligaments. Ligaments attach bone to bone, and we're going to look at ligaments and tendons in a second. And then tendons attach bones to muscle. And so all of these things have to work together in order for this system to work, right? They're different types of tissues. And remember, different types of tissues working towards the same goal is considered an organ. And then all of those organs together make up the skeletal system. So, one of the interesting things about the skeletal system is that as an adult, you have about 206 bones. When you're born, you have close to 300 bones. And it's because your bones aren't fused together. They're not like one long bone. But if you think about it, it sort of makes sense, right? When a new baby's brought home, everybody's like, "Oh, be careful of its head, be careful of its head." And if you look really closely, sometimes you can see the baby's heart beating at the top of its head. And the reason for that is because the bones in its head haven't fused together yet. Okay. And so it makes it easier when the mom is giving birth if the baby's head isn't one big solid mass, right? If it can move a little bit and be a little bit pliable when it's moving down the birth canal, it makes it a little bit easier for everybody. Okay. So 300 when you're born, about 206 when you're an adult. So let's look at a couple of other functions that bones have. And so one of the big functions is it's the site of blood cell production. Your blood cells are actually made in your long bones. And so when you hear about somebody having a bone marrow transplant, very often the problem that they're having is with their blood. And so they can get a bone marrow transplant. And so in your long bones, that's where your blood cells are being produced. Support we talked about, movement we talked about, protection we talked about, storage of ions we didn't talk about. And we're only going to look at this a little bit, right? So your bones are made out of calcium and phosphorus, and so your body also needs calcium and phosphorus for other things. And so your body has to maintain that balance. If there's not enough calcium in your body will start taking it from your bones. So an example of that is people who have the eating disorder anorexia. Anorexia is it's a devastating mental health issue where people, and it's not just women, men and women, they look in a mirror and they can be 90 pounds and they literally see themselves as fat. And so there's a disconnect. And so they don't eat enough food, right? They literally are starving themselves. Well, In order for your nervous system to work properly, you have to have calcium ions, and that's that storage of ions that we're talking about here. And so, in order for your body to have the right amount of calcium, if you're not getting enough food, your body's going to go to your bones and it's going to start taking some of the calcium out of your bones. And so, very often, people that have been anorexic for an extended period of time, their bones become weakened, along with a lot of other things, but their bones become weakened. And so storage of ions is one of the big jobs of the bones. And then the last thing is endocrine regulation. So endocrine has to do with hormones. Now, it's funny because everybody always thinks of bones as being like the support system, right? And until relatively recently, we didn't know that bones had any kind of endocrine regulation at all. And one of the things that it does regulate is it can make people it can have a role in glucose intolerance. So it's a very long, complicated thing that it's relatively new. But what we think of is hormones. Bones are actually part of that. Okay, I know that sounded kind of lost and convoluted, but I don't want to get into any details that are just absolutely not necessary here. So we're going to move on. So um, protection. Okay, so this makes sense, I think, to most people, right? You wear a helmet so you can protect your brain. Well, your cranium, right? Your skull is protecting your brain too. It's protecting your eyes. Still wear a helmet, right? Because it can use extra protection. And then your ribs are protecting your lungs and protecting your heart. And then the the spinal cord it's about this big, and it's the spinal cord runs all the way down from the base of your brain all the way down your back, right? Well, that's where all the nerves, all the nerve impulses go to get up into your brain. And so something has to protect that. And what protects it is your vertebrae. Your spinal cord is protected by the bones that sort of wrap around there. Okay? So big, 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 big job. Your bones can be really, really long, like the femur, and really strong, like the femur, right? There are people that have broken their femurs, right? Like people break their femurs playing hockey, a really bad bump if you're playing hockey. People have broken them playing football. People have broken them just falling downstairs and you just hit the right way. Car accidents can break this bone, but in order to break this bone, this is a strong, strong bone. Has to be a lot of pressure. Now, that's one. The smallest bone in the body is something called a stapes. And so a stapes is a little tiny, very fragile bone that's in the inner ear, that's in the middle ear. And so that's the smallest bone, and femur is the largest bone. Remember, 206 as an adult. So what is the bone made out of? So it's made out of cells. So that means that the bone itself is living. It's made of different cells, different kinds of cells, and they do different things. And there's different layers. Now, one of the really cool things about bones is that they are surprisingly light given how big they are and how strong they are. And so they have something it's called spongy bone, and it looks like there's a bunch of little holes in it. Now, the bone is perfectly healthy with all these holes, right? But because of the way it's structured, the bone can be very strong, but it's also lightweight, and it makes it a little bit more flexible, right? You don't want your bone snapping every time you run into a wall, right? You want to have a little bit of flexibility. And so, middle of the bones is where the bone marrow would be, and those cells are always being produced because your blood cells last for about 120 days, and then they have to get replaced. So that's what a bone is made out of. So it has different tissues with different kinds of cells. So that means that a bone is actually an organ. One of the other things that is part of the skeletal system is something called a tendon. And so your tendons are they're very, very tough fibers that attach bones to muscles. So it's showing a hand on the left. And so when you move your hand, right, you can feel the tendons at the top of your hand. And it's moving the muscle, right? And another one is in the calf of your leg. There's something called an Achilles tendon. So at the end of the gastrocnemius muscle, at the end of the calf muscle, you have this tendon, which is right here. Let me see if I can. So it's right here. I can never work this darn thing right. There we go. And so this thing right here is called the Achilles tendon. Notice it's attached to the back of the calf muscle, and it's attached to the heel. So I used to play a lot of racquetball, and this was, oh geez, mid 80s, 90s, and I used to play a lot of racquetball. And so racquetballs are indoor rooms, and it's kind of like a really fast game of tennis, but not really. You're bouncing off balls. It can be anywhere from two people to teams in there. And so I was playing a guy, a game of racquetball, and he went back, and he was really way better than me. And he went back to slam a shot. When he did, the back of his heel hit the back wall in the back of the court, and this thing snapped. He was in a cast for months. You could hear it snap. That's how tight and how strong that Achilles tendon is. And so whether there was some kind of defect in it or he just hit it the wrong way, it was an awful sound, and it echoed in the room. It was just awful. And so those tendons, so Achilles tendons on the back, and that comes from, and Achilles was a Greek figure, right? That was his weakness, was his heel. That's where that comes from. And so those are tendons. And then ligaments are something else. So ligaments connect bone to bone. And here we have a picture of the foot, right? And then the muscle, the bones in the bottom of the leg. These are the ligaments. So these ligaments are actually holding bones together, right? So remember, tendons are bone and muscle, and then ligaments are bone to bone. Okay, so I think that's it for this. It is, and so we're gonna stop this one here. And remember, I'm gonna put it up at the top for you. I'm gonna put it underneath skeletal system. So if you want to come and just watch this part, you can do that. All right, so I'm going to stop this, and then we'll be back in a couple minutes with the muscular system.